In this video, we're going to apply L'Hopital's rule to find the limit of an indeterminate form produced by a difference. And it says evaluate the following limit using L'Hopital's rule. And they say limit as x approaches 4 from the right of 8 divided by 2x squared minus 12x plus 16 minus x over 2x minus 8. So this actually gives you a situation where you have infinity minus infinity. Okay, and the reason that occurs is because they're approaching 4 from the right. If I were to plug something like 4.0001 into this bottom function here, I get something very small. So I'm going to just prove that. We're going to plug that in, 2x squared minus 12x plus 16. I'm going to plug in something like 4.000001, store it as x, and grab that equation. I get a really small number. And if I take 8 divided by that number, I get a really large number. And this occurs on this side as well. So I get a really large number. And I can make that number as small as I want. So I can make that infinitely small. So you can see that we're going to get infinity minus infinity here when I plug in something that's really close to 4. That is indeterminate. So to use L'Hopital's rule, I already have fractions, but I need to combine those together. So let's write limit as x approaches 4 from the right. And then let's combine these together with a common denominator. So I'm going to multiply 8 times 2x minus 8, the other denominator. And then that's going to be over 2x squared minus 12x plus 16 times 2x minus 8. And then I'm going to do the same thing to this x over here. I'm going to multiply x times 2x squared minus 12x plus 16 over, and then 2x minus 8 is going to be multiplied by 2x squared minus 12x plus 16. So I found a common denominator now. I'm going to combine those together. So we're going to have limit as x approaches 4 from the right. When I distribute here, I get 16x minus 64. When I distribute the negative x on top, I get minus 2x cubed plus 12x squared minus 16x. And this is all over, and I'm going to actually distribute the bottom too. 2x squared times 2x would be 4x cubed. 2x squared times negative 8 is negative 16x squared. Negative 12x times this 2x would be negative 24x squared. Negative 12x times the negative 8 would be positive, let's make sure I don't mess up any multiplying, 12 times 8, 96, so plus 96x. And then 16 times 2 is 32. And then 16 times 8 is negative 128. Let's combine some like terms. So I'm just going to write that the limit should be here. Negative 16x cancels with 16x, and I get negative 2x cubed plus 12x squared minus 64. All over, in the denominator, does anything cancel? No, but we can combine some stuff together, so we can write 4x cubed. We can combine the negative 16 and the negative 24 should be negative 40 x squared. So we've taken care of these two pieces. Then 96 and 32, 128x, and then minus 128. Now we're in a good spot to apply L'Hopital's rule. So we're going to say the limit as x approaches 4 from the right, and we're going to take the derivative of the top equation. and do the same thing to the denominator. And we can do this over and over and over again until we find a limit. Derivative on top will be negative, so when I say limit, as x approaches 4 from the right, we end up with a negative 6x squared plus 24x and derivative of negative 64 is 0. So over 12x squared minus 80x, 12x squared minus 80x plus 128. So we're going to want to evaluate that. So we're going to plug that in the calculator and see what we get. So negative 6x squared plus 24x, and then 12x squared minus 80x plus 128. Okay, so we're getting, when we plug that in right now, we're getting something that's going to get us close to where we want to be. But I think we should take the derivative again. And if we work ourselves down by taking the derivative again, we should end up getting, what we want. Let's see, if I take 4, stored as x. Yeah, so we're going to keep taking this derivative until we get this down to something that gives us an answer. So let's take the derivative on the top and the bottom again. So we're going to say limit as x approaches 4 from the right, derivative of the top over derivative of the bottom. When I take the derivatives, I get limit as x approaches 4 from the right. That'd be negative 12x plus 24 over 24x minus 80. And then I'm going to take the derivative again. So I got limit as x approaches 4 from the right. Let's see, would I want to do that? Let's plug in negative 12 times 4 divided by okay, if I evaluate this limit now, so I plug in the 4, so we're going to plug this 4 in, we end up with negative 12 times 4 plus 24 over 24 times 4 minus 80. We end up with the limit, or we end up with, that gives you negative 3. So negative 48 plus 24, that's negative 24 over 24 times 4 is 96. So 96 minus 80 is 16. That reduces to negative 3/2. So we can say that the limit as x approaches 4 from the right of our original function, f of x, is equal to negative 3/2. That's an application of L'Hopital's rule.